So this question is broken up into two parts. The first part is going to be very similar to what we just did. The only difference will be that the formula we use will be different because now the police car is moving away from the listener, so we're going to have a different equation to use. The temperature hasn't changed, so therefore the speed of sound is still 343 meters per second. And the speed of the source is still 25, but we're just going to use the different equation with the opposite sign to account for the fact that now it's moving away from us. So for part A, we can just use our Doppler effect equation. Adjusted frequency equals the frequency of the source times the speed of sound divided by the speed of sound plus the frequency of the speed of the source, that is. So we go back to our original frequency of 1600 hertz for Fs. And then for the ratio, we're going to have 343 divided by 343 plus 25. So now we can see we're going to get a lower frequency as we would expect because the source is moving away from us. Therefore those wavelengths are a little bit longer than they would be if it were at rest. So we get about 1,490 hertz. And with 2 sig figs, we should really just go ahead and round it to 1,500 hertz. I'm going to keep that frequency, though, in my calculator, so for part B, I can use the exact value that I have of 1,491 hertz. All right, so there's our answer for part A. For part B, if I want to know what the wavelength of the sound that reaches my ear would be, well, that's actually not very hard to do at all. I can just go back to the fact that for any wave, the speed is the wavelength times the frequency. And so to solve this for wavelength, I can just do the speed divided by the frequency of the sound. The speed of sound in air, when it's 20 degrees Celsius at least, we already found that to be 343 meters per second. And we just found the frequency, and I'll wait and round at the end, so I'm going to use all the sig figs I got in the last one, all the digits. 1,491 hertz, which remember means per second, so you can see how the per second and hertz are going to cancel. And we end up getting about 0.23 meters.